Hello everybody. Good morning or good afternoon to some of you. Thank you for taking time out of your day to join us. Today we will be looking at open source management, and we will be doing this through the lens of Temenos, the world's leading banking software company. Our agenda for today is to hear from Martin Bailey, Director of Products at Temenos, how they are managing open source. Then Rami Sass, CEO of WhiteSource, will tell us why open source management is important and how you can do it effortlessly, followed by a quick demo of our solution. And then, if time will permit, a few questions. Please notice you have a toolbar for Q&A, and you can post your questions in during the session. We will try to answer some at the end, but we promise full answers at the end of the webinar. Now, Martin, do you want to take it away?
Hi, my name is Martin Bailey. I'm from Temenos. I'd like to tell you about our journey with WhiteSource software. First of all, let me tell you a little bit about the company. So Temenos is a banking software company. We only do banking, we don't do anything else. And we're a product company. We're totally focused around our products and how we can give our customers the best value. We're completely innovation-led, so we spend more on R&D than anybody else in the industry. And of course, it's completely meaningless unless you deliver the value and get those clients live. And we take a client live once every 3 days, which is the fastest in the industry. Just a few numbers. So roughly 500 million customers rely on Temenos for their daily banking needs. There's a huge amount of assets under management with Temenos software. So it really is mission critical software that has to do a very important job. I'm Martin Bailey, so I'm a product director for technology within Temenos. What that means is that I work for product development, and my job is to make sure that the non-functional aspects of our products are absolutely top class. So that means looking after the platform, looking after the security, performance, all of the oily bits. So open source has been something that's been close to our heart for a long time. It's very important to us to get the best productivity. And often the best way to do that is to utilize the open source software that's available. But our clients are very risk averse. They're very concerned about any kind of risks in the products that they take. And it's a very common question for our prospects in the RFP process to ask about open source software and compliance. So before we met WhiteSource, what we used to do was we used to scan our software manually using nothing much more than grep, really, looking for different keywords, and we used to keep a list of open source components that way. Obviously it's very labor intensive, very error prone, and not an ideal solution. So we were really looking for some software to make that job a hell of a lot easier. Because obviously we get asked that question quite a lot. We want a way to get back to our prospects as quickly and as comprehensively as possible and give them the confidence to choose our software. So before we met WhiteSource, as I say, it was a manual exercise to basically look through our software, search for what we had in there, basically catalog it, and basically deliver that information to our prospects and clients. What we now do is we've integrated WhiteSource into our build process. So basically every time that a developer commits a change, a build is kicked off, and in that build process the WhiteSource software scans our libraries and basically looks at what we've got inside of our code. We manage it via policies, so we have a black list and a white list. The blacklist is obviously stuff that we really don't want to see in our software, and the whitelist is stuff that we are completely happy with. And quite importantly to us, we've got a report available whenever we need it that shows us what we've got available. So the way we manage our open source components is that we've got our policies in place. The policies are very easy to set up. We literally chose the open source that we were happy with and added it to the whitelist. We chose the open source software that we were not happy with. We added that to a blacklist. And basically, the build process checks every time we do a build to make sure that A, there's nothing on the blacklist that's crept into our software, and B, that we're happy with everything that's in there. It's all very efficient, and basically we don't really have to do anything. It's all integrated into our build process. An added benefit is that WhiteSource also scans for security vulnerabilities that are known about in the open source components that are out there. And this has proved quite useful already, because we have on one occasion found a security vulnerability which we wouldn't otherwise have known about, and we were very quickly able to address that and fix it and get it into the code and get it out to our clients. It's very important to us. So really it took us not very much time at all to set up the build process. I think we had a call with the WhiteSource engineers. It took us roughly half an hour per build process to get everything up and running and working. And once we got it up and running and working, it was really something that we could forget about, because there was no need to go back and do any maintenance on that process. It just worked, and it's been working ever since, and we're very happy with it. And the reward is that we now know exactly what we've got. We now know that we're compliant with the policies that we have in place. We can answer the prospect queries absolutely honestly, completely and comprehensively, and we can know that the information we're providing them is 100% accurate. So a very good result all round. So we're very happy with the software. And that's just about it from me. So thank you for your time, and I'm sure if you've got any questions, I'll be happy to answer them.
Unmuted.
Okay, thank you very much, Martin. Rami, do you want to start presenting your part?
Thank you, Maya. Thank you, Martin, very much for that. Before I dive in, I just want to take a quick administrative note and let everyone know that you can type any questions that you have during this session in the chat box, and we will try to address them at the end, or send full answers via email to anyone who's registered to this webinar as a follow-up. So having said that, and following Martin's remarks, I would like to do the following. First, tell you a little bit more about what's important about opening open source in general, and licensing and security more specifically, and a little bit about the WhiteSource solution and how we approach these issues. And then I will show you a demo, a walkthrough of our service, what it actually looks like, so you can get a better understanding of the type of actions that you can do, reports you can get, and what value you get from using the WhiteSource solution. Okay, with that, we'll start. So everyone knows that open source is great. Pretty much everyone that uses, everyone that develops commercial software today relies very heavily on open source. Various researches show that the majority of a software distribution, commercial software distribution, is actually comprised of open source components, and that the software vendor actually only focuses on its own core competence and spends very little time on things that were already developed by others and that are basically commodities. So open source is not a surprise that it's a booming industry, and it's only growing in an exponential rate over the last few years. Unfortunately, there are a few things that prevent the engineering teams from fully realizing the benefits of open source. The top two potentially hazardous issues that we identify are, firstly, licensing and compliance issues, and secondly, security vulnerabilities that come with the component. So if a component has a vulnerability and you embed it in your software, then your software inherently becomes vulnerable. And when those two are combined, they can dramatically reduce the value that open source brings with it to your engineering organization. From a licensing and compliance perspective, you know open source is free, but it does come with a lot of strings attached. Every open source must have a license text in order to even be open source. A piece of software cannot be considered open source unless it has a license attached to it. And those things are actually quite difficult to track and to police or govern, primarily because open source components are software in their own right, and they can depend on more open source components, which in turn can depend on additional components and so on and so forth. And there is no assurance that those transitive dependencies will have the same license as the original component that brought them along. And those create very serious gaps in what the organization can even know about its own content of open source components, much less its ability to enforce their policy. So if you have a licensing policy, like we've heard Martin mention that they do, in the form of a whitelist and blacklist or any other form, you will have a very hard time enforcing your policy because it is very difficult to even be aware to a full extent of all of your components that are being used by the developer. From a security perspective, it's more of a good news, bad news situation, where the good news is that the open source community, at least for the good and well-maintained open source projects, are doing a fine job of monitoring, tracking, and then patching for security issues that are being found in their project. The bad news is that there is generally a disconnect between all of that fine work done in the community and what the end users are aware of. So an engineering team normally uses a few hundred different components, open source components, and as mentioned before, they don't even know about all of them, much less have the attention span and resources to keep track on each and every one and find out what the community is up to and what issues have been found, and then be able to fix them or patch the new version or do the required activity in order to resolve the vulnerability. So that means that most R&D organizations end up using old components that have known vulnerabilities and don't even know about it, where in fact there are very easy fixes that can be applied very quickly, but the existence of this knowledge gap prevents those engineering teams from, again, enjoying the full benefits of their open source components. And instead, they end up introducing unnecessary vulnerabilities into their own software. So this is where we come in. We at WhiteSource provide a cloud-based software and service solution that is fully automated, works well with all the modern agile, DevOps, and continuous integration environments and methodologies, is extremely easy to use and implement, and is generally affordable both at the purchase cost, but I would say even more so at the amount of internal resources and manual labor that the service takes by removing the developers from burden of tracking open source components that are being used, trying to research their licenses, trying to figure out if they are vulnerable or not. You get all of that completely automatically by implementing the WhiteSource solution. From a licensing and compliance perspective, we are able to very quickly and then continuously monitor all of the open source components that are being used by engineering, and then automatically know about all of their licenses and the licenses of their dependencies, and provide all the necessary information for the organization to comply with those licenses. And on top of that, we also provide a very easy to use policy system that is then automatically enforced by the WhiteSource solution. So within minutes of installation and defining your policy, you're basically good to go. Developers don't need to spend any more time tracking and researching licenses, and your policies are proactively enforced without you having to break a sweat. For security, what we do is we actually have integrated our service with various online repositories that monitor for security vulnerabilities, and we know how to match those vulnerabilities, only the relevant vulnerabilities, directly to specific open source components with specific versions. So we will only let you know about real issues that impact you, and we're also able to help you know about fixes and new versions as soon as they go out, so you have a very easy time fixing or resolving the vulnerabilities. And there are a few scenarios here. One is where developers add new libraries that have security vulnerabilities. Immediately you will get some alert on that. And two, when a new security vulnerability is discovered for an existing component in your inventory, that will also trigger an alert by the service and allow you to take immediate action and resolve the issue. The way that we work is that we integrate with all the common build tools, so we fit in well at the build phase of the software development lifecycle. We have many out-of-the-box plugins to all the leading build tools out there, and it takes literally 5 to 10 minutes to install one of our plugins, and then a few more minutes to have the system crunch the data and then present you with the full listing of the inventory and all related information, licensing, security, and other information that we can present. And the plugins, the nice thing about them is that they do not read your code and would never transfer your code over to the cloud. They simply look at the binaries, the third-party files, take some signature that serves as a unique identifier for each file, and just transmit the list of those signatures over to our server. So there is no exposure to any intellectual property, and you don't need to worry about sending any sensitive information to a cloud environment. The main benefit, or the immediate benefit rather, is that the developers, the engineers, are taken out of this loop, and they can invest more of their time doing actual work, doing their own R&D, and not worry about licenses or security issues, or even which open source depends on which other open source, and so on. And these are all things that they don't really care about. They only want the functionality that they can get from the open source, and then go on to their next task and not worry about it anymore. So to sum up everything, I think the main value you would get from using the WhiteSource service is that it removes any manual labor or effort or internal resources that are being spent trying to track and monitor open source usage, and then trying to comply with legal issues and or track security vulnerabilities and fix them. And at this point, I'd like to switch over to the demo part of our presentation. and I'll show you what our system actually looks like. So being a cloud-based software as a service solution, outside of the plugin in your build environment, there's nothing to install, maintain, or update. We do all of that centrally in the cloud for you. You can simply log in to your account using your browser and then get access to a set of dashboards and reports that show you various aspects of your open source inventory and usage. And what we're looking at right now is the main dashboard, or the organizational dashboard, that's generally divided into three parts. The top part is the alert, which I'll get back to in a minute. The middle section is a mini inventory broken down into products. So for each of your products, you can see the list of components being used and their licenses, and a breakdown of risk factors for those licenses. And at the bottom is the ticketing system for new libraries coming in, or the libraries that were added recently by developers and that for some reason were not handled by an automated policy. I will show you policies as well in a minute. But on now and again, libraries are not necessarily handled by a policy, and then a ticket would be open and an email would be sent, and someone would have to intervene and take a decision and educate a decision about what to do with those libraries. In any event, in any point in the system, you can drill into a given library and get much more information about it, including its dependencies, its known versions, older or newer than the one that you're using, useful links to its homepage or bug tracking system or code repository, etc. And also drill into the license, where for the popular OSI licenses, we've done some basic risk analysis. It's not meant to replace legal advice. You should still definitely consult with your consul or external legal advisor. It's just a shortcut for you to try and get a feel for how potentially hazardous the license is, and again, enable you in making your choices better. Now, if I go back to the alerts, so once the system knows what your inventory is made up of, it can start producing some insights into those components. And you can see we have all these different types of alerts, including security vulnerabilities, policy rejections, new version alert that lets you know when there is a newer version out to a component that you're using. And all of these things have their own dedicated reports. So for example, you can open the vulnerabilities report and get all of the vulnerable libraries listed in one place, where they can be sorted by severity. So you can prioritize what you want to handle first. And here, much like in every other report, you can drill in and get more information, in this case about the vulnerability, the full disclosure, the severity information, its impact on your system. So these vulnerable libraries, where are they in different projects that you're developing, and links to potential fixes, workarounds, patches, and anything that can help you mitigate this issue. We also have a few other reports. The most basic one is an inventory report. It's just a flat list of all of the components with a short description for each, a note about the license and appearances in various projects. And all of our reports can be exported to an Excel spreadsheet and then can be shared with a partner, investor, provided to a customer on demand, sent over to a legal or an auditor that needs to see these things, and all with a click of a button. And again, the nice thing here is that it takes 10, 15 minutes to integrate and upload information, and you're good to go with a click of the mouse. You are able to produce these full and accurate and comprehensive reports that include all of the licensing information down to the last dependency, and provide them as necessary. Okay, next and lastly, I want to talk about the policies. So we have a few types of policies, but the two most common ones, and also the ones that Martin mentioned, are a blacklist and whitelist of license types, where in our example, we don't like the GPL family of licenses, so we can simply select them from the list of known licenses and then mark them to be automatically rejected by the system. And on the other hand, there are quite a few licenses that we are okay with, including BSD, Apache, MIT, and the like, and those we mark to be automatically approved. This is done correctly, then we should be left with a very thin gray area of libraries that would ever require manual intervention. For the most part, this runs on autopilot. Libraries coming in are being checked against the policies and are handled automatically, where policy rejection can result in one of two scenarios. One is that it pops an alert and sends an email to the relevant person that needs to take action, speak to the developer, or make a decision about the existence of that library in their software. And two is the more restrictive type, where it ties back to the plugin in the build system and then fails the build. So in fact, you can gate your system and prevent developers from ever adding libraries that are considered problematic by organization by actively enforcing your policies directly in the build environment. So in our example, if a developer is trying to add some library that has a dependency that's licensed under GPL, his build would fail and he would get a full report back in his build tool listing what happened, telling him that he cannot use the specific library in that dependency, telling him what the policy is, and forcing him basically to find an alternative in real time before he's had a chance to invest any effort or integration or testing or anything in that library that he is forbidden to use. So in fact, we provide a preventive tool that lets you steer clear of potential open source issues rather than having to deal with them post hoc after the R&D team has spent a lot of time integrating them and working around them, where it becomes very, very painful to try and take those components out and replace them with either other components or with fresh code that you would need to insert in order to complete your development. We also provide a few other types of policies, including security-based policies and the ability to limit the age of the library that you are tolerant for. So you can say that you don't want any libraries that are older than 4 years to enter your product, and so on. And all of these policies that we've just seen are at the organizational level, but then if you want to tailor different policies for different products, you can do that. For example, if you have a mobile application and a desktop application and a back end that's an online server, those may have different strategies for open source licenses that are acceptable, and also different tolerance levels for security issues and even the library age, or different vendors that are allowed to integrate components in them. So that's very easily applicable by just doing product-specific policies for each of our products, and then the system is able to apply and enforce those policies selectively for your individual product. Okay, and with that, I think we covered the basic functionality of the system, and we've seen the demo. And let's see if we have any questions.
Okay, so
did we get any questions from the audience?
Yeah. So our first question is from Michael. He's asking, do I need to upload my own code into your cloud service? What assurances do I have about confidentiality of my code?
Right, so that's a good question. I want to stress that, again, we do not look at your code. We are not a code scanner. We don't do static code analysis. WhiteSource never ever reads the proprietary code that is written by the engineers. We only look at third-party binary files and then take a checksum of those files and upload to our server. So we would never take any code and upload it to the cloud. We don't even read the code, we don't scan the code, and we do not risk any intellectual property that belongs to our customers.
Okay, we have another question from William. Do you report on security vulnerabilities and other bugs discovered in open source components that I use?
Right, yes. So the way our security system works is we do not scan the actual open source components and try to figure out if they are vulnerable. Rather, we look at publicly available repositories that have reports about, or not necessarily open source, they have reports about any type of software vulnerabilities. We filter out the ones that talk about open source components and are then, using a relatively sophisticated system we've developed, are able to match them to specific versions of specific components. So you get reports that are accurate and tell you about real, actual vulnerabilities that exist and are known to exist in the components and are in fact exposures to your software should you integrate those components.
Okay. Chris is asking, do you integrate with Jenkins CI server?
Right. It's another good question. Not only with Jenkins, of course we integrate with Jenkins, but we cover a very wide range of build servers and build tools. I'm showing some of them on my screen. They include Jenkins, TeamCity, Bamboo, Microsoft TFS, and then for tools, Maven, Gradle, the Python setup tools, the Ruby bundler. For .NET, we have some options with Nant, and also for JavaScript with NPM, Grunt, Bower, and others. And the rest of the languages like C, C++, JavaScript, PHP, Objective-C, and others are covered by a generic command line importer that can be integrated with any other build tool or any script that is used to build your software.
Okay, and we have one last question from Aaron. He's asking, how does your algorithm detect the open source component that are used, especially if you are not reading the source code?
Okay, so we at build time look at all the third-party binaries that are entered into the build. For each of those, we take a checksum which uniquely identifies each of the files, and then send a list of those checksums over to our server. On our server, we have already conducted a very extensive search at one point, and then on a daily basis, we expand our database by doing more searches to find repositories that host open source components, which we then download and extract that same checksum to match the unique identifier to the metadata relating to that library. So by having the list of those checksums, we are able to provide information from our database that relates to the files that these checksums came from, including their licenses, dependencies, versions, security vulnerabilities, and so on, everything that we've seen in the demo. Okay. So with that, I think we shall conclude. I'd like to thank everyone that's taken the time to join us today, and specifically Martin for his very informative and enlightening talk. And I hope to see all of you soon elsewhere. So thank you very much, and goodbye for now.